Let's now work some examples that pertain to parallelograms and the specific types of parallelograms. Each figure is a parallelogram, so that is given to us. It is a parallelogram. Not asking us, is it? It is. Identify the special type of parallelogram, so we will either call it a rectangle, a rhombus, or a square. Explaining our reasoning, giving one of the properties listed on the list of properties side. So what do I see here? Nothing about the sides, nothing about the angles. I see about diagonals. So my reasoning here is going to be something about the diagonals. Remember these guys here? These are called the diagonals. Well, I see that the diagonals have different marks, so I know the diagonals are not congruent. What I do see, though, is the diagonals are intersecting at a right angle. The diagonals are perpendicular. So because the diagonals are perpendicular, I look back to my list of properties and I see which one that goes for. Do you want to look back at your list of properties? Do you see that it's for a rhombus? So that's what we will answer. This is a rhombus because the diagonals are perpendicular. So rhombus is what we call that one. Let's take a look at the next one. Now here you might see, oh, only two sides are congruent. However, remember we were told that these are all parallelograms. Parallelograms has opposite sides congruent. So if this has one slash, the opposite side should have one slash. If this has one slash, the opposite side should have one slash. Similarly, if this is a right angle, across from it should be the same size angle, right? Opposite angles are congruent in a parallelogram. Then if the angles next to each other are supposed to add up to 180 and this one's 90, this one also should be 90. Similarly, this one will be 90. So because it's a parallelogram, I was able to fill in all of those things. Now I ask myself, what do I see in the picture? I see that the sides are all congruent and the angles are all congruent, or I can say they're all 90 degrees. They're all right angles. So which one does it make? Well, the sides being congruent makes it a rhombus. The angles being congruent makes it a rectangle. So if it's both, that means it's a square. So we call this a square. Square is the correct answer because it's both a rhombus and a rectangle. Let's look at the last one. Again, it's a parallelogram. That was told to me at the beginning. Therefore, if one angle is a right angle, the opposite is right, and the consecutive is right as well. What I see here is that all the angles are congruent, or 90 degrees. What property does that go with? Rectangle. So in my last one, I have a rectangle because all the angles are congruent. Rectangle. Let's take a look at how to solve problems once we already know what type of parallelogram we're looking at. The diagonals of rhombus, WXYZ, intersect at point V. Given that the measure of angle XZY equals 34 degrees, XZY, 34 degrees, and WV equals 7, WV 7, find the indicated measure. Now here's what I'm going to do first before I try to figure these out. It's a rhombus. So what do I know about a rhombus? Let's mark it in the picture. Because it's a rhombus, I think to myself, 4 congruent sides, diagonals perpendicular, and diagonals bisect angles. So I'm going to draw that in my picture. 4 congruent sides, diagonals perpendicular, and diagonals bisect angles. Those are congruent to those, and those are congruent with those. That's going to help me immensely without having to do too much work. Okay, I get to see a visual in this picture. Now remember that a rhombus is a parallelogram, so all of the parallelogram properties exist too, such as the diagonals bisect each other. That piece is congruent to that piece, and this piece is congruent to this piece. So if WV is 7, VY also 7. Let's go ahead and see what's being asked for over here. The measure of angle WZV. Here's W down to Z and up to V. Well, from my congruent marks, this isn't difficult. I see this is 34 and this one's supposed to be the same, so this one's also 34 degrees, of course, because it's an angle. Let's see how we're going to figure out ZY. Where is ZY? ZY is this guy right here. Well, I know he's supposed to be congruent to the other sides, but I don't know how much the other sides are. Let's look around and maybe try to take on a shape that we know, such as this figure right here is a triangle. More specifically, because of this right angle, it is a right triangle. In fact, you may feel a little bit better drawing this separate from the picture to help it be more clear. Now remember how we said the diagonal was bisected, so if that's 7, that's also 7. Let's mark it in our picture. This down here was given as 34 degrees. Let's mark it in our picture. And ZY was the one that we wanted to know. So let's call this the one we want to know. Maybe we'll put a question mark there. Okay, if you want to call it X or something, feel free. I'm not going to use X because an X was used in the angle up here. How do I figure out this side of a right triangle when I know an angle and a side opposite from that angle? Are you thinking SOHCAHTOA? It'd be good if you were. Why SOHCAHTOA? Because I have an angle, and opposite from that angle, I have a side. What's this side called? It's across from the right angle, so it's the hypotenuse. Opposite and hypotenuse, that's going to be sine. So I set up my equation. Sine of 34 degrees equals opposite 7 over hypotenuse question mark. What do we do when the variable's in the bottom? Interchange property. Question mark equals 7 divided by the sine of 34 degrees. Now, make sure your calculator is in degree mode. 7 divided by the sine of 34 degrees is approximately 12.5. So we get about 12.5 for ZY. Let's take a look at another set of problems that pertain to rectangles. The diagonals of rectangle PQRS intersect at point T. Given that the measure of angle RPS is 62 degrees, where's that? RPS, 62 degrees, and QS is 18. Now that's not shown in the picture, but here's QS. We know that that whole length is 18, and remember that when we have a parallelogram, the diagonals are bisected. So each part, what does it have to be? 9. And that's probably why it wasn't shown in the picture. It's hard to label the whole length when it's been intersected by another length. Find the indicated measure. Well, rectangle. The two things I know about a rectangle, memorize them, list them off. 4 congruent angles. More than just congruent, they are 90 degrees. Also, the diagonals are congruent. So those two, both 9 and 9. 4 angles that are 90 degrees, let's draw those. 90, 90, 90, 90. They are congruent. Well, that's going to help us a little bit because if this is 90, 90 minus 62 gives us that adjacent angle. How much is that? 28. 28 degrees in here. And remember, if all the angles are congruent, they have to have those same measures. So tiny angles 28, tiny angles 28, tiny angles 28, tiny angles 28. Larger angles 62, larger angles 62, larger angles 62. All the angles are congruent. Let's go ahead and see what we're asked to find. Measure of angle QPR. Q over to P, down to R. Well, guess what? We already found it, 28 degrees. How about ST? ST is right here. Well, guess what? We already marked it. 9. So much easier when you mark everything you know in the picture. But the hard part is memorizing all that stuff. You can do it. Let's look at one more scenario. Now we have a square. So what is a square? Everything that is a rhombus and everything that is a rectangle. So think of all of those properties, mark it in your picture. We see that square EFGH diagonals intersect at J, point J, right here. Given that GJ is 15, that's labeled, find the indicated measure. So remember a rhombus, 4 congruent sides. Diagonals perpendicular. Diagonals bisect the opposite angles. Well, as I mark these, remember it's also a rectangle, which means all 4 angles are congruent. So I'm not going to put different marks here because all 4 angles are congruent and 90 degrees. Well, that helps me out a little bit because now I know how to divide evenly up those 2 congruent angles. Also in a rectangle, besides having those 4 90-degree angles in a rectangle, what about the diagonals? The diagonals are congruent too. That's for a rectangle. Okay, let's see what we can do for these missing measures. Angle EJF. EJF. Guess what? We already marked it because we knew it was a rhombus, 90 degrees. How about FH? FH. Well, if this guy said 15 and we marked all these the same, this one was 15 and this one was 15. Put those together, 15 plus 15, and we get 30. See? Not too bad once you label your whole picture.